First, I would like to thank the organizers to give me a possibility to talk with you. I'm actually coming from another point of the research. You are talking about the data, about the processing the data, but I'm coming from the part where the data are actually produced. And I would like to show you how, especially when you are dealing with, what are the problems and how can be used, especially in the interdisciplinary collaboration done with the, also with the computer science. So, as we said, that food and nutrition compositional data are actually there are two different parts, but nevertheless, they are much more connected together, especially when we are dealing with the food characterization. We are dealing about the quality of food, about the safety, authenticity, traceability, security, sustainability. And this is very important. And when Thomas said, you are what you eat, it's really then actually expressed also in our nutritional habits. And based on the food, we can evaluate the nutritional variation of the plants, analyzing relationship between nutrition and intake and disease, and establishing dietary guidelines. However, every country has their own standards. Every country has their own, I would say, a different compound that are important. And it's very difficult on a global scale to make a dietary guidelines for the whole population. Also, when you are dealing with the nutrition dietary guidelines, you have to take into account also the, I would say, the heritage, cultural differences, and also other issues that need to be taken into account. And therefore, food and nutritional compositional data should be standardized and also should be, I would say, standardized in a way that a global population can use it. So all the data that we are producing has to be put into some kind of the databases. And when you are dealing with the databases, you have to know, you are much more used than I am, what are the rules, what are the standard procedures, how this data will be shared. And what is also very important is the vocabulary, ontology, and data forest. Why? Because me as a chemist, I know that one compound has different names, has different vocabulary. Sometimes these names can be connected together with the so-called CAS number, but nevertheless, not all one number cannot take into account the compounds that you are putting in your database. And of course, all of this data can have also the metadata. Then when you are putting the database together, you need to know where you have the already existing data, and databases you have to find out and connect them. And of course, these are intersectorally because, of course, all the data can be produced not only by the chemists, physicists, but can be also not only natural sciences, but also the social sciences. And when these data are putting together, you have to think about the platform software, which has to be user-friendly, front and user interface, but this is more connected to your expertise. But what is also important is validation of the data, because this data will be also used as officially recognized. That means that maybe sometimes the official bodies can show you or can have a warning system to see if all the data can be actually, if some trust to this data can be connected. Also, the data should be validated and certificated, which means that the laboratory which produced this data has to have some laboratory standards. And what is the most important at the moment is the management of this data. Who are the ownership of this data? Who has the access rights? The quality manager should know which data are really good. Will this data be open access, or do we need some funding, and how we can actually we can deal with the intellectual properties? So all these things, when you are creating a database, need to be really taken into account and also need to be standardized. And if you want to build such a database, usually it takes you 5 to 7 years. So My presentation is divided into 3 different parts. In the first part, I would like to show you how actually the metrology in the food, that means how our laboratories who producing the data should take into consideration all the issues to get really robust and quality data that you can then play with them. This is actually a part of the so-called MetroFood infrastructure that was established in 2018, and now it is in a phase that it goes into the S3 ERIC. And the main point, I would say, and the main objective of this MetroFood research infrastructure is how to connect the physical infrastructure with the electronic one. And we want to standardize the electronic infrastructure and building the databases and the methods that they can be then used for user-friendly for different populations and different stakeholders. I'm mainly related into the, I would say, to the physical infrastructure. In the physical infrastructure, we have to deal with the data. And I will show you an example how important this data and what I would say the quality of the data are for that need to be included into the database. So usually when the laboratory is producing the data, it has to have standard operational procedures, the sample pretreatment. They has to do with the reference material, measurement uncertainty, and they has to be also involved in the interlaboratory comparison. So that means that their data are really reliable. And one of the issues in the MetroFood research infrastructure was also to the development of the new reference material. Why? Because MetroFood is a quite huge project dealing with 48 institutions, and therefore to cooperate with all these interdisciplinary research, I would say, institutions, we need to prove that we are able to be interoperable. Therefore, we develop a new reference material based on oyster tissues and the rice, and for their characterization and interlaboratory comparisons. Important for this is that this reference material was done for many classes of parameters, including nutrients, organic contaminants, inorganic contaminants, and also for origin and authenticity development. And in this intercomparison, 39 laboratories were involved using different identified different compounds. And we found out that actually when we are dealing with the food safety, that in determining the elements, it was quite good. The results were quite good, taking into account or taking different methods. And for example, this is only one example of arsenic. We found very comparable results. In the second part, where we are taking only the protein content in food characterization is some kind of the standard compound that need to be identified. And you can see here that actually later on, not all the laboratories made it satisfactory. Based on the, I would say, 4 or 5 laboratories, one of them, which is already accredited, which already have the measurement, I would say, operational procedure available, it was not successful. But I don't want to say which of the laboratory is not successful. I just want to point out that when you are dealing with the data, you should take into account where these data are coming from, who is producing this data with this data, are all the procedures that they need to be to obtain the robust data are taking into the consideration. So this was one of the examples that we are why we need the computer science and technology. The second one is how I would say the databases that they are produced for different food can be used for food authenticity and traceability. When you have a food control, you can have different systems to trace your food globally. And in the traceability system, you can have labeling and radio tagging, but this is not always useful for all the food. For example, for fish, and also this tagging is usually put into the packaging material, and this packaging material can be then changed during the transport. Also, the documents the documents can be falsified. That means that we have that although we have some systems to put into the traceability system, they are still vulnerable. The food is still vulnerable to fraud. So we need robust analytical techniques for food origin and authenticity, and where we can help ourselves with stable isotopes. And why stable isotopes? Because actually, that means the meteorological variations can be actually transported or can be seen as a fingerprint coming from the environment into the food and then into the people. So you know that the precipitation I made from water, that means 2 hydrogen and 1 oxygen isotopes, but these isotopes are not the same. 1 are heavier, 1 are lighter, but this signal is changing according to the geographical conditions, according to the distance from the sea, altitude, and other parameters. We also have the photosynthesis, different photosynthetic cycles of the carbon, and we can see the different isotopic composition that can be expressed in the plants and then transported into the plants. And in case that we are dealing with the fertilizers and the isotopic composition of nitrogen, we can even identify the plants, or that means the food which was organically produced. So, taking into account the stable isotopic composition, you can see that you can get a fingerprint coming from the environment into the plants, into the animals, into the food, and also into the human bodies, which can be actually related to the biological climate, the geological conditions, and anthropogenic sources. So, just for the terminology, usually when you are dealing with the data, you always have express the concentrations in percentage in milligrams per grams. But here the terminology is a bit different, because in the environment we have the lighter isotopes, which is in much higher abundance comparing to the heavier one, and because of this we have these data are actually expressed in the delta notation according to a suitable standard, which means that any deviation of the standard means that you have in your sample more carbon-12 or more carbon-13. In case that we have more negative values, you have more carbon-12, for example, or lighter isotope, or and opposite, if you are dealing with the higher values, you have more carbon-13, or that means more heavier isotope. So when you are dealing with the traceability using the isotopes, you need to actually identify the isotopic composition of the water, because then you know where your water is coming from, depending on the altitude, as I say, distance from the sea, and also processes affecting the evaporation of the water. Dealing with the carbon, you can then differentiate different photosynthetic cycles that they are actually using, that the plants are using, and any combination between or mixture between different plants or different food can show you the adulteration. For example, you can see here that the C4 plants like corn, they have higher isotopic composition. That means that they have more carbon comparing to the cane sugars, for example, where the isotopic composition is different. And in case of nitrogen, especially when you are dealing with the organic food, you can see that the isotopic composition is usually enriched with nitrogen 15. So the food also have different isotopic composition than the food that was produced using the synthetic fertilizers. So when you are dealing with the origin of the food in the environment, and why is this important? This is important especially because we believe that the food coming from a special origin and that, that it has the special mark to be protected, has a better quality, and it has a different taste. And if you want to identify the food on the market, the origin of this food, you need to do different steps. You need to build actually the database, which is usually composed not only from the isotopic composition, but also elemental composition. You need to establish the models, because based on these models, you can differentiate what are the differences between the food composition, and then you need to make the classification. So then you can prove that your sample, that your food is really from that country. Usually, this to prove the authenticity and provenience, you need a special database of authentic samples, and these authentic samples need to be, all isotopic variability need to be taken into account: geographical origin, climate conditions, soil pedology, geology, and any effect that it is also influencing the process technology in order to define the origin. Also what is important is that this is you need a very large number of the data, which is very expensive, and this has to be regulated, that means regularly updated, in order to get the stability and the right models for the identification. At the moment, on the European level, only one database is operational, and this is based on the isotope, which includes isotopic composition of wine. Some other databases are related to the special needs, for example, for Grana Padano cheese. And because of the expense, now new methods need to be established. That means that we want to define the origin of the food, to predict the origin of the food based on the isotopic maps, which can be created according to the geoclimatic factors. Of course, at the moment, this is very difficult because we don't know all the, I would say, environmental factors which influence the isotopic composition of precipitation, and also not only precipitation, also the soil. And also what is also important, especially when you are dealing with this isotopic map, is that annual and seasonal stability has not been proven. So, in order to get more, I would say, less expensive authentication system, you need in the future to establish isotopic maps based on the predicted data. How does this work? Or how does the fingerprint is working? So in case that you want to see if your shellfish is really from Australia, or for example, if isotopic values of wine are similar to other regions, you need the database, and you have to compare your data with the database. And in case that you need to predict, that you need to do the predictive application, that means that you want to predict what are the isotopic values of the rice coming from the Italy, or for example, the data that they are marked, or that means the olive oil, which is marked to be Italian, does really not match the isotopic values. What in that case, you need actually the prediction map, which can be based on the data obtained from the soils, climate, geography, and the water spatial layers. And based on this, you can then see if really or predict the location, and really if your food is coming from the predicted region. And of course, because to establish such a database, you need very good data. There are special, useful, practical guide that is proposed by the forensics community, and you can see here that how many steps you have to check in order to obtain the very good data. And now I'm going to show you two different examples based on the database that was established, for example, and the statistical models that were developed based on the database. And for example, it was very nice. Here it's very nicely seen how the Grana Padano cheese can be actually separated or can be distinguished according to the other cheese. This was done based on the isotopic composition and database of the Grana Padano community and based on the random forest model. And then we have another example, for example, when you want to define if you want to verify if your sample is really from the country. And here is the example of the Slovenian milk when we actually propose the linear discriminant analysis when we distinguish the Slovenian samples between the other samples coming from other countries. And you can see here that the Slovenian samples taken from the market really match our authentic samples. So this is one of the proof that of the correct labeling. But these databases cannot only be used for food, but can also be used for the drugs. And here is one of the examples. So based on the database, which was verified with the different models, we can distinguish the drugs coming from different companies and from different pharmaceutical companies. So actually we have two different examples that when we want to define the authenticity. One is that you can build an isoscape based on the precipitation data, plant isotopic composition, and olive oil. That means that we need to know the isotopic composition of precipitation. We need to know the climate, that means temperature, precipitation amount, and biology. That means how the isotopic composition is changing during the biosynthesis. And based on this, you can predict isoscapes and you can do the prediction. Or you can take the real example when you can build all isoscapes based on the real data. That means that based on the 150 samples, you can obtain the isoscapes. You can do the statistical evaluation and connection into the precipitation data, and then you can see if these and you can build these isoscapes, and then you can compare your data if you want to verify the origin of your sample. So based on this, I would say, authenticity data, we also built the so-called IsoFood ontology. And the inspiration of this IsoFood ontology, which was done in collaboration with Tome, was the paper published in PANAST by the US groups, where they establish a need to a centralized repository for isotopic data set. That means that we need an isobank which has to be organized, consolidate, and share across different disciplines, because not only food authenticity can use this data, but also environmental or I would say other communities can use them. And our IsoFood ontology was actually established and was composed based by these parameters, that is samples, location, measurement, and also inventory data. And it was published in Food Chemistry. And what is also important that the organization of our ontology was linked to the Richfield ontology already established, and also to the EFSA ontology, which already have the ontology related to the food safety. And listening to the second presentation, maybe most probably it will be very good to connect this ontology to the nutritional ontology as well. Why it's called ISOFood? This is because our project was which was finishing last year, was inspiring us to connect, I would say, computer science with environmental sciences. So how does look like this ontology? First of all, we make the relationship related to the isotopic composition and the sample data. So when you are dealing with the sample data, you have to define what kind of food are you going to analyze. And that means, what kind of parameters are you going to analyze in your food? Are you satisfied with your bulk analysis, or maybe lipid analysis, or maybe you can go further and to get fatty acids, amino acids, and other analysis which can help you to identify the sources and the processes with how the food was established. The second part, which is also important, is the relation to the isotopic and measurement data. That means you have to connect the ontology with the laboratory which was performed this analysis. So you have to check which laboratory was using this, what was the methodology, what are the reference, what is the quality control, so that really you are really sure that these data are robust and can be comparable to other databases available globally. And the third part, which is also important, is you have to make a relationship related to isotopic and data and the location. That means that you need to find out where is your food, or that means the source of your food was growing, what are the climate conditions, pedology, what are your I would say input parameters of precipitation, and this can be very easily also connected to the global network of isotopes in precipitation managed by the Atomic Energy. But you also have the first data operating like an open access, where the isotopic composition of the precipitation on the whole globe is available, which was actually coordinated by University of Utah. So why all this, what I was talking about, is important, especially for food business operators. This is important, especially because the people who want to protect their good quality products, they need some kind of traceability and some kind of system and databases. Then inspection bodies, because they want to establish the first warning system if the food is not really in compliance with the standards, with the regulations. Also the researchers and the academy, this is very important, especially when you are dealing with the databases. You have to think about, because the databases can be very helpful and can reduce the European money actually to the researchers, because you already know what databases are already available, and that means that you cannot you cannot give money for the same research, for example. This is also important. And also the consumers and citizens issues, because we have to build on the trust. The people has to trust to the food standards. The people have to trust to the food that they eat, and also to the diets that you are actually dietary uptakes, I would say. And of course, this work cannot be done without the group from the Jožef Stefan Institute and the project that at the moment are still operating. And I would like to thank you for your attention. And if you have any questions,